And then all of a sudden, just like a switch, right? That I did that interview and nobody would engage me. That's actually what I found to be the most frightening part of all of this is literally the basic foundations for the practice of science have disappeared, including open discussions of contentious scientific topics.
I am a husband, a father, a lawyer, a Christian, and a proud Canadian. I started this series because it was clear that our nation needs truth. Not just another biased narrative, but real information of substance. We need access to facts and the freedom to think for ourselves. I'm Leighton Grey, and this is Grey Matter.
Hello, everyone. Welcome to another episode of Grey Matter. Well, I know many of you are probably exhausted by the subject of COVID-19. You wish that we could never talk about it again. Unfortunately, we must. We must because it's not over. In fact, a strong case could be made for the idea that we are just at the beginning of the arc, the historical arc that will be the COVID-19 pandemic story, particularly because of the vaccines. In fact, as time goes on, it seems more and more that the pandemic is about the vaccines, more so than lockdowns or anything else that happened during that period. And of course, in order to provide you with the best information, the best knowledge, so you can use your gray matter to think about and assess what's going on, we try to bring on the most truthful, most authoritative, and most courageous people who can inform us about these topics. And we have one of those today. He's Dr. Byram Bridle. Welcome to the program, sir. It's great to have you on.
Hi, Leighton. Yeah, it's my pleasure to be here. Thanks for hosting me.
So before we dive in and get to know him a bit better, in fact, hopefully a lot better, we're going to go to our framing aphorisms. Of course, these have a particularly vaccination and COVID bent. The first one is from Dr. Anthony Fauci, who is under a great deal of scrutiny right now, and he deserves every bit of it, who said, "I believe I have a personal responsibility to make a positive impact on society." If you remove the word positive and insert the word negative, you probably get closer to the bone there. The second one is from her counterpart in Canada, Theresa Tam, who said, "Misinformation or distrust of vaccines can be like a contagion that can spread as fast as measles." The next one is from some people that our guest knows too well, who said, "Therefore, we wish to state publicly that as scientists, faculty, and or staff of the University of Guelph, we stand firmly against the continued spread of factually incorrect and misleading information that is being disseminated by Dr. Bridle. We have confidence that the SARS-CoV-2 vaccines approved for use in Canada are safe and effective, and we wish to reassure the public that as members of the University of Guelph community, we fully support evidence-based public health, which includes vaccination against COVID-19. In response, our guest said this. He said, quote, "We made a big mistake. We thought the spike protein was a great target antigen. We never knew the spike protein itself was a toxin and was a pathogenic protein. So by vaccinating people, we are inadvertently inoculating them with a toxin." Well, who do we have on the show today? Well, it's Dr. Byram Bridle. He's an expert in oncology, cancer therapeutics, immunotherapy, oncolytic virotherapy, translational oncology, and chemical studies. In other words, he knows a lot about cancer. He's an associate professor of viral immunology, Department of Pathobiology, University of Guelph, and also part of the Ontario Veterinary College. He has an impressive education, which includes a BSc in biomedical science, an MSc in immunology, and a PhD in immunology. So this is a person who is qualified to and has testified as an expert in court and in other government inquiries about vaccines and about immunology. But he's also very much under attack, someone who has suffered greatly from the attacks on truth in science by the people who I would describe as advocating scientism versus true science. So, Dr. Bridle, I really enjoyed meeting you recently and wanted to get you on the show. And here you are. I want to start off with talking about a very successful project that you completed about finding new treatments for osteosarcoma This is the cancer that killed Terry Fox. When I was researching you, I found this, and I was very intrigued by it. I wonder if you could tell us a little bit about this research that you did.
Yeah. So Leighton, that's an interesting area of research that I was doing, and actually it addresses something very important. There's this piece of misinformation that's being propagated by legacy media. So I recently attended an event and spoke at an event in Calgary, right? Just a week and a half
Injection of
ago.
truth. Yeah,
Yeah,
right.
yeah, the event, yeah, that event, an injection of truth, and it was quite interesting because legacy media went right off the rocker on that, right? Got so
They sure
emotionally
did.
triggered.
Yeah.
Uh, but one of the things that was interesting is the only thing that they seem to be able to come up with, that to use quotes against me, was the fact that I mean some of your legacy media there in Alberta actually outright stated that I'm a veterinarian, and I'm
Yeah.
not. I don't
Yeah.
have my Doctor of Veterinary Medicine degree. I can't be a veterinarian. And in fact, my training, as you noted, is at a much higher level than that, right? That
Hmm.
the MD and DVM represent uh, professional undergraduate degrees, and I
Yeah,
actually
you're a
have
professor of
my.
immunology.
That's right. I actually
Yeah.
teach health professionals. I teach
Hmm.
vaccinology and virology and immunology and cancer biology to the health professionals. And so this project that you brought up really highlights nicely, I think, where a lot of this confusion comes from, because I am located at the Ontario Veterinary College. And what a lot of people don't realize is I actually had competing job offers. So after my PhD, I I was a postdoctoral fellow for 6 years at the medical school at McMaster University,
Oh, really?
and that's where I really learned to become a viral immunologist.
Hmm.
Uh, and when uh, so I actually had two competing job offers when I started my independent academic career. So that would be starting off as an assistant professor, and those two, so the competing offers were from the University of Guelph, where I would be located in the Ontario Veterinary College, as well as the Ottawa Hospital, where I would be affiliated with the University of Ottawa
Hmm.
and their medical school. And so I weighed the two, and this is what a lot of people don't realize when it comes to so-called human-centered or human-focused medical research. The majority of that research is actually what I often jokingly refer to as it falls under the realm of verminology, and I sometimes jokingly refer to it as that because what a lot of people don't realize is over 97% of human focused biomedical research is actually done using rat and mouse models.
Really?
And I was doing that extensively when I was associated with the medical school at McMaster University. And of course, I'd be able to do that same research if I went to the University of Ottawa. But I can do the exact same research as well where I am at the Ontario Veterinary College. In fact, when you think about it, when it comes to animal modeling, veterinary college is an ideal place to be when it
Hmm.
deals with when you think about working with any kind of animals. So
Right.
when I was weighing this, I saw I could do the same mouse and rat focused, so-called human focused preclinical and translational research at the University of Ottawa and at the University of Guelph. But the advantage at the University of Guelph, which was a substantial one as I saw it, was that if I, by coming into the Ontario Veterinary College, I had the opportunity to work with what we call advanced translational animal models. And what I'm referring to there is the fact that we have cats and dogs, pets, coming through the Ontario Veterinary College all the time who experience the same types of diseases that we do as people. They spontaneously develop cancers just like we do. And notably, we know that the environment, right, a person's environment has a great contribution, in fact, to the development of cancers. And these animals share our environments, right? They live in the exact same environments. They drink the same water,
Mhm.
etc., as their owners do. And so we have these unique animal models that represents, they develop spontaneous cancers, the same types of cancers, the same spectrum of cancers as people do. Then they also spontaneous infectious diseases, just like we do. They also represent especially when you go across animal breeds, they represent a very genetically diverse population, which also mirrors the human population, right? We're dealing with a lot of genetic diversity. Whereas when we're working with mice and rats, we're dealing with highly artificial animal models. These are almost always animals that are extensively inbred, so that each animal is almost genetically identical to every other animal in the study. So for a lot of these studies, we're dealing with when we're doing research on cancers or infectious diseases in these rodents. There's hardly any variability represented.
Mm.
And so really, and this is the interesting thing, Leighton. So when a person, uh, publications, peer-reviewed publications have shown this, especially in the area of cancer research. That is the area where there is by far the highest failure rate for every, when it comes to the translation of promising cancer therapies in what we call our preclinical models. So again, that would normally be mice and rats where that research is beginning. And then people would traditionally take these gigantic leaps from mice and rats to humans, to go
Right.
into human clinical trials. And these, and when it came to cancer, for every 20 cancer focused clinical trials that were run, at least 19 would fail to yield anything at the end of these clinical trials that was useful for the human population.
Wow.
And people have to understand this human clinical trial pipeline is incredibly expensive. It costs tens of millions of dollars to navigate right through to the end of a phase 3 clinical trial. And yet there's over a 90% failure rate. So my philosophy was to try and change this, and to change this by fundamentally changing how we conduct research by doing research in advanced animal models, what I like to call advanced animal models. So these
Mm-hmm.
highly outbred, very diverse populations of animals that share a lot of the environmental insults and injuries that we're exposed to as people, and see if we can conduct the research in those animals, because the idea being that since they so much better recapitulate the diseases that we experience as humans, that if we can find things that are successful in these animal models, these advanced translational animal models, that we would have a much higher success translating these, making that leap
Mm-hmm.
from
Mm-hmm.
the cats and the dogs to humans and
That
human
makes
clinical
sense.
trials. And so that we could have a lot more success in those clinical trials and make much more efficient use of those millions and millions of dollars that are being
Mm-hmm.
invested into those clinical trials.
Mm-hmm.
And so when I came to the University of Guelph, this was actually very broadly recognized. And so that's the reason why I'm at the Ontario Veterinary College, is to do this advanced animal-based research. And so this is broadly recognized. So I got funding the University of Guelph had never received before, that they were very proud of. For example, I was funded by the Terry Fox Research Institute. I
Right. I
also
saw that.
received,
Mm-hmm.
yeah, and I received funding from the Canadian Breast Cancer Foundation. Interestingly, uh, one of the projects that I ran, it was the first ever clinical trial in animals that the Canadian Breast Cancer Foundation had ever funded. And what we did is we actually
Really?
tested a novel vaccine strategy that I had developed and that I had published. And we tested this strategy in cats that had what we call mammary carcinomas. So there are a lot of nuances. So that's the equivalent. So mammary carcinoma, that is, in people, we would call that breast cancer. We don't
Right.
actually call it breast cancer in cats because cats technically don't have breasts.
Right.
So we refer to it by its proper medical name, which is mammary carcinoma. But nevertheless, it's the equivalent of breast cancer in people. So we treated cats and tested this in cats as a way to accelerate our progress into human clinical trials. And like I said, that was funded by the Canadian Breast Cancer Foundation. And indeed, that vaccine technology then advanced. It was taken by a company and advanced into 4 human clinical trials. Right. So clearly, the research that I do with vaccines is very much human focused.
Mm-hmm.
My goal is to ultimately, benefit people, and if we can benefit animals as a bonus, that's
Mm-hmm.
great. Uh, and then you're right. So following that, the Terry Fox Research Institute recognized the value of this research program, and so they provided me with funding to then test some of my cancer immunotherapy ideas in the context of dogs with osteosarcomas. So that's bone cancer. And that's very interesting because dogs is very just like people. So in fact, dogs. So one of the problems in terms of trying to do research as it relates to bone cancers in people is actually it's a relatively rare disease, a relatively rare cancer in people, but it's very common in dogs, in fact, and treated very similarly. So you mentioned Terry Fox. Just like Terry Fox, as you might recall, he had to have one of his legs amputated, and typically
Right.
these bone cancers in the dogs present in one of their legs as well. And so they typically have to have one of their legs amputated. And what ends up killing these dogs almost always is the metastatic disease. And where it tends to spread by far the most often in dogs is the same as people, spreads to the lungs. And
Mm-hmm.
ultimately, what these dogs will die from is metastatic cancer in the lungs. And that's exactly what killed Terry Fox, right? The exact same disease
Mm-hmm.
progression. It was when the bone cancer migrated into his lungs, right? That's ultimately what killed him as well. And so the Terry
Mm-hmm.
Fox Research Institute was very interested in this and recognized the value of doing this research. So yeah, that's been an exciting part and sort of foundation of my research program at the University of Guelph
Mm-hmm.
for quite a few years now, and one that they've really publicized quite extensively.
So obviously, you're a very eminent scientist doing cutting edge research. One thing, a question I have, Dr. Bridle, for those of us who are lay people, is could you explain the relationship between the development of cancers in the body and the activity of the immune system? What's the relationship between immunology and cancer? Because for most people who don't understand medicine or what you do, those things don't seem to go together. But there's an explanation here, I sense. Could you provide that for us?
Yeah, thanks for asking that because you're right. Traditionally, in medicine, the role of the immune system was largely ignored, and yet it plays an incredibly foundational role in preventing cancers, in the development of cancers, and in the treatment of cancers, as we've learned more recently. So this stems from the idea. This is very interesting. This becomes very fundamental, and actually, in every introductory lecture I give in my immunology course to students, I always include this very topic that you just asked. Because, so for example, when I was trained in
Oh, great.
immunology,
So I'm on the
late
right track. That's good news.
absolutely. Yeah, it's very fundamental. See, when I was trained in immunology, I was taught that the immune system only responded to things that are foreign to the body, right? But now that's completely changed. We recognize that what the immune system responds to are things that are dangerous to the body. And that, importantly, can include dangerous self, right? Which would be cancer cells. Cancer cells are derived from self. What cancer is a disease of dysregulated cell growth. It's when cells lose the shutoff switches, right? That control cell growth. And so they start proliferating
Mm-hmm.
uncontrollably. That's when a cancer forms. That's a very dangerous scenario. And our immune system is capable of recognizing dangerous self and responding to it. So this is the interesting thing we now understand. And I teach this as what's called, the technical term, Leighton, would be called the immunoediting hypothesis. And I won't get into all the complex
Okay.
details here, right? But for a lay audience, what that essentially means is that the concept is this: many of us probably have had cancerous cells, especially as we get older. We may have had cancerous cells appear in our body, a few times. You and I may have had cancerous cells appear in our body, but we were never diagnosed with cancer. They never progressed to what we would call the clinical condition of cancer because our immune system did one of two things. It recognized those early cancerous cells as dangerous and either eliminated them from the body or drove those cells into what we call a state of equilibrium. So you can think of it like a teeter totter. So if the immune system
Mm-hmm.
wins, right,
Right.
then you get elimination of the cancer cells, and the cancer cells are gone. And so those few cancer cells never progress to a large enough tumor, right, for it to become clinically relevant. So you never feel sick. Uh, and you never get diagnosed with the cancer, and those are removed. Now, if the battle between the
Mm-hmm.
cancer cells and the immune system are about equal, right, that teeter totter stays even. And we call that a state of equilibrium, which means, for all we know, for example, you and I could potentially have a few cancer cells in our body right now, but if our immune system is keeping that in a state of equilibrium, again, they can't grow, right? They can't grow to control. Their
Oh,
rate of cell
fascinating.
growth equals the ability of the immune system to kill those cells, and they don't grow, they don't progress. And therefore, we
Hmm.
never reach the point
Hmm.
of a clinically relevant case of cancer. And it's very interesting.
Wow.
We know this is a fact
I can see why
because
you're
when
so,
pathologists,
yeah, yeah. I can see why you've dedicated your life to studying this.
yeah, exactly. So there's been many cases where pathologists have done postmortems on people for other disease conditions, and inadvertently, while doing the postmortem, found tumors. So tiny tumors that the person was never even
Oh.
aware of, and
Hmm.
the physicians with which they worked were never aware that they were even present. So we know this happens. And so this is the thing.
Hmm.
So technically, when a cancer grows, progresses to the point where somebody starts feeling ill as a result of it, right? And physicians can use their diagnostic technology to diagnose it as a cancer. Technically, by definition, for that tumor to have reached that point, it had to have been able to find ways to evade the immune system, because their immune system is very good at finding these cells and getting rid of them. So, technically speaking,
Right. Right.
every clinical case of a cancer is one in which that cancer has developed what we call immunoevasive properties. So, you can
Mm.
see the immune system plays a foundational role in preventing, getting rid of these cancer cells before it can even be diagnosed as a cancer, or controlling their growth before it can be diagnosed as a cancer, or again, it applies pressure, a selective pressure that dictates the very nature of the cancers that end up developing in people. And so, by
Mm.
understanding this latter part, right, the fact that these tumors, in order to grow, have had to evade the immune system, we can now use this information, right, and we can use all of our knowledge about all of the effective mechanisms that our immune system has to fight off these cancers, and knowing that the tumors have developed tricks or strategies, right, to bypass this, we can now intervene, and we can manipulate this war between the immune system and cancers, right? And to do that, we refer to that as immunotherapy. So we come
Mm.
in with things, and it can be a vaccine. It can even be a vaccine technology. I've done a lot of work with that, a lot of research with so-called cancer vaccines. It could be, an antibody that we come in with. There's so many different strategies, but the point being that, especially with these cancers, when we can identify how they've evaded the immune system, if we can either shut down or compromise those evasive properties of the tumor, then we tip the balance back in favor of the immune system, right?
Mhm.
Or we directly engage the immune system, right, and educate it so that we strengthen the effector mechanisms, the anti-cancer mechanisms, right, to again tip the balance in favor of the immune system, right?
Mhm.
And so that's an entire field in and of itself. Yeah, so I've been fascinated, right? And here's two quick things that I think you and your audience will be interested in, Leighton. One is the uh, this idea we now appreciate, and this is quite remarkable. We now appreciate that so many so many of the most effective traditional ways to treat cancer. So let me give you an example. Chemotherapeutic drugs. They're basically poisons that we give to the body. And the goal is to poison and kill the cancer before we poison and kill the patient. And if it looks like the latter is going to happen, we have to back off. And that usually means that we're getting into a palliative care situation, right? And the person ultimately is going to die from the cancer. But there are chemotherapeutic drugs that are much more effective than others. And this is very fascinating, Leighton. What we now understand is the most effective chemotherapeutic drugs trigger immune responses. One of the ways that they work at their core, we think of them, so their direct mechanism of action is basically functioning as a poison for the cancer cells, but they also trigger immune responses against the cancer. So in fact, if you use these same chemotherapeutic drugs in an animal model where you've stripped it of its immune system, they don't work nearly as well. And
Mhm.
so what's interesting is now we know there's radiation therapy and chemotherapy, chemotherapeutics that induce what we call it, Leighton, is we call it immunogenic cancer cell death. Immunogenic
Mhm.
just means it grabs the attention of the immune system. It helps the immune system recognize that cancer that had otherwise evaded it as something that's dangerous and that should be responded to, and that should be removed from the body. So we now understand, which we never did historically, right? Everybody thought chemotherapy, radiation therapy, surgery, right? Surgical excision of tumors had nothing to do with the immune system. It has all kinds of things to do with the immune system. Even surgery has a big impact. Surgery itself, a major surgery, is highly immunosuppressive. It's highly immunosuppressive. And now we understand when doing surgeries, especially if we're going to implement new immunotherapies, right? We now have to decide: do we implement that therapy before or after the surgery? Because it's going to be after the surgery. We have to wait until that immunosuppressive period is gone, right? Or the immune system isn't going to respond properly. So we open a window for potential regrowth of the tumor, or we administer it beforehand, right? But knowing that beforehand, when you have an established tumor, that tumor is quite immunosuppressive, right? So there's pros and cons. But this is the thing. So every aspect of cancer therapy now, Leighton, even when it seems like it has nothing to do directly with cancer immunotherapy, right? The immune system has become a critical consideration for every aspect of cancer therapy now. It's really quite fascinating. And then, of course, the other one that's interesting is just the whole milieu of new tools. And the reason why I get excited about immunotherapy is this. Think about when you and I get an infection, right? We get a cold. Our immune system is very good at getting rid of that virus, right? Let's say you or I, we will have had colds over our lives. Let's say it's caused by a rhinovirus, right?
Sure.
You get a minor cold, the virus gets removed from the body by the immune system. You recover, you're fine, right? You don't have all kinds of off-target damage, right? We don't live the rest of our lives with terrible side effects and disabilities, right, from that. Unlike somebody maybe who's been treated with chemotherapy, right, extensive chemotherapy regimen. And the reason is because our immune system is designed to respond with exquisite, and in immunology we like to use the term exquisite specificity, right? That's the hallmark. We call it the hallmark of an immune response, is exquisite specificity. It's able to target and remove dangerous things from the body without causing too much overt harm to the normal cells in the body, right? That's why we're able to recover from minor infections all the time and suffer no ill long-term consequences. And that's what I get excited about with cancers, because everybody knows that with traditional cancer therapies, they are very blunt tools. And there is all kinds of horrible side effects associated with it. So I see in the future the possibility of harnessing the power of the immune system to, with great specificity, and because of its inherent potency, right, effectively eliminate cancers from people's body without all of the horrific long-term side effects that are associated with traditional therapies.
Very, very interesting. Well, speaking of immunology and being immune, you seem to be somewhat immune from cancel culture attack and from oppressive treatment by the University of Guelph. I saw a post that you made on your Substack a couple of months ago that reads, "Today represents a horrible milestone, one that I would never wish upon any of my colleagues, including those who have most brutally and incessantly harassed and defamed me in social media because I dared speak truths at a time when it was deemed inconvenient. It has been precisely 1,000 days since the administration of my employer, University of Guelph, locked me out of my office and laboratory. You say I spoke scientifically validated truths about COVID-19 when much of the world was not ready to hear them. Doctor, what were those truths? And why were you treated, and why do you continue to be so badly treated by the University of Guelph, and indeed, let's call it most of the quote-unquote scientific community?"
Yeah, so all this time later, right, it's been almost 3 years. And I look back and I still find it remarkable, because I think, anybody who talks to me, who just gives me the opportunity to chat with them, I think it becomes pretty evident that I understand what I'm talking about, right? That I have expertise. I'm a genuine.
That was my impression. That's why I brought you on the program.
Yeah. And so, okay, what this comes down to, Leighton, is this. What you just referred to. This all dates back to one famous interview that I gave, now famous interview. And it was way back in May of 2021. And it was a short radio show segment, 9 minutes long. The radio show was on point. The person who was interviewing me, her name is Alex Pearson. She by the way did nothing wrong. She just asked me one question, one straightforward, simple question. She had no idea what I was going to say, but she was a subject matter expert, and she had me on and interviewed me several times prior to that as well, and it was never an issue. Uh, and in that interview, this is what she asked me. She asked me if I felt that if I had any concern that there might be a link between the modified RNA COVID-19 shots and cases of myocarditis that were being observed at an unusually high frequency in young males in Israel. And Israel was the focus at that time because they were well ahead of us in terms of the rollout of the
Yes, I
COVID-19
recall
shots.
this. Yeah. Yes, I recall they were claiming almost
Yeah,
100% vaccination. Yeah.
exactly. And so that was the question. And my response, so it's interesting because you made reference at the beginning of this to a letter that was written by and signed by 88 of my colleagues at the University of Guelph,
Right.
in which I need to point out that they, in that letter, actually misquoted me and misrepresented what I said. Right?
What
I actually
what a
have a full
what a shock.
transcript, of
What
course,
a
of that.
shock.
You as a lawyer would be familiar with the importance. Yeah, you'd be familiar with as a lawyer with the importance of transcripts and how important
Hmm.
it is to be precise with the wording. But this is the thing. My answer was essentially this, and there were three things that were considered very controversial at that time. First, I said, and I didn't say definitively that there was a link. I said I do think there is a potential link. That there might be a potential link between the modified RNA shots and cases of myocarditis. Well,
Hmm.
now all this time later, I don't think I even have to try and defend that at all. It's common knowledge that myocarditis is associated with these shots. I
You're
mean,
ahead of the curve.
you
Yeah.
don't have to. We don't have to defend it. The vaccine manufacturers have accepted that a long time ago. It's on the vaccine inserts now. Everybody recognizes that. But my goodness, at that time, Leighton, that was, I mean, that was just an
Oh
egregious
yeah.
truth to
Heresy.
be proclaiming. And then
Hmm.
the other
Hmm.
two things is because when you do see the potential for a problem, right, and a potential association with the problem, as a scientist, you always ask yourself, is there a potential mechanism of action, right? Because at the end of the day,
Hmm.
what you have is you have a correlation, right? There's an intervention, and you're seeing, and when that intervention is applied, you're seeing an increased incidence of something. In this case, the harm was myocarditis. So when you see a correlation, as a scientist, you start asking yourself, are there mechanisms of action that would legitimize this, right? That would suggest this is a cause and effect relationship, right?
Hmm.
Not just a simple correlation.
Right.
And I had been studying documents, and I've been meeting with a lot of international, colleagues who also had concerns that were growing at that time. And in meeting with one of them, they brought my attention to a document. It's interesting because this individual, they specialize more on the clinical side, not the preclinical side. So I don't think at the time they fully grasped the importance of this preclinical study, but they brought my attention to, in a discussion, preclinical data that they had found. People say that I had actually submitted a Freedom of Information request. I hadn't actually. That was a misinterpretation. I I learned about it from an international colleague that they on the website. Now it was buried deep in the website, but it was publicly available. But again, virtually nobody would be able to find it unless you knew it existed there. There was a document, a biodistribution study that Pfizer had submitted to the Japanese Health Regulatory Agency. So I had looked at that, and it was shocking to me because what it unveiled to me, and it wasn't the scientific data that shocked me so much. In fact, because what it showed was that the lipid nanoparticles that carry these modified RNAs, right? So that's these lipid nanoparticles, these little fat bubbles, are the foundation of the technology for the Pfizer Moderna shots, right? The,
Hmm.
the, the so-called modified RNA, lipid nanoparticle encapsulated, modified RNA COVID-19 vaccine. And it showed that these lipid nanoparticles got distributed throughout the body and at disconcertingly high concentrations in some organs and tissues, including, for example, the ovaries and the adrenal glands really stood out to me. And so that finding of itself was not what shocked me, Leighton. What shocked me about it was that people had been expressing lots of concern about the potential for these novel gene-based vaccines to fundamentally alter their own DNA, right? Incorporate into their own chromosomes. And I'll never forget, because regulatory agencies and health regulatory officials and even government officials who have no expertise in this area and should not have been speaking wanted to assure the whole public that there was no risk of any genetic alteration to themselves, to their own cells. And the way they expressed that is they told everybody in the public, including myself, right, that these worked just like traditional vaccine technologies, and then went so far to describe how a traditional vaccine technology, and they were insinuating these modified RNA shots were like this. They get injected and they stay at the injection site, right? A little bit of the material will go to the local draining lymph nodes, which is true. That's what you want, because that's where your immune response gets initiated. That's why if you get sick, a physician, for example, if you have a throat infection, they'll often palpate just under the jawline, because if they feel a swollen lymph node, that's objective confirmation that your body's mounting an immune response against, a throat infection. So what was surprising to me was I knew that in the over decade of the development of this technology leading up to its rollout, that these lipid nanoparticles got distributed far and wide throughout the body. That was in fact the intended purpose, because they were supposed to be used, they were being developed for use as gene therapies and drug delivery vehicles. For example, to treat brain cancers, to use these little fat bubbles to deliver multiple doses of chemotherapeutic drugs to brain cancers is just one of many examples.
Right.
So you obviously didn't want them to stay in the arm if you're trying to get them to the brain cancer. So I knew that. So what shocked me was I had heard that public messaging. And at the same token, because I at the time had trust and faith in our health regulatory agencies, I had no reason to question their messaging. When they said that these things stay at the injection site, for me personally, behind the scenes, I was like, whoa, this is not at all like this technology has ever behaved. But remember, we were told when disclosing the ingredients of most of the ingredients were disclosed, but there were some proprietary aspects of the technology that were not disclosed, and we were told that was to protect the intellectual property. Now, I hold several patents, and I even have a current patent pending.
Right.
I understand the value of intellectual property, fine. So as a scientist, I'm sitting here thinking, okay, there's nothing in these ingredients that suggest, in the ingredient list that I can see, that would suggest that these things should be limited to the injection site and just the local draining lymph nodes. But there's a proprietary aspect. So they're telling me that that's how it behaves. It behaves completely differently than the technology ever did before. So I'm sitting there thinking, wow, they've come up with some kind of proprietary tweak that completely changes how this technology operates.
Right.
Now it stays at the injection site. I was like, wow, someday I hope we can find out what this proprietary technology is, because this is an amazing adjustment to this technology, like just a miraculous change in how it behaves. So you can imagine how upset I was, Leighton, when I saw this biodistribution data submitted from Pfizer, and I'm saying, no, it behaves exactly how it always has.
Right.
And so the shock to me was, we've been lied to, and why? Right? But I never got to get to that in the interview, because I was trying to stay focused on the science. But the whole point is, I'm thinking, okay, myocarditis. Okay, and so now, that's involving the heart. But you have things that it only stays the injection site. But you see how I was starting to make the link, a mechanistic link here?
Yes.
A potential mechanistic link. So if there's a link between the shots and the heart, having systemic biodistribution means you could get the vaccine or components thereof, or even what I call the derivative of those vaccines, which is the spike protein, right? The spike protein is not in the vaccine. It's encoded by the messenger RNA and gets produced by the cells that receive that genetic blueprint. So I call it the derivative of. So the point being, now I understood that the vaccine or components thereof or the spike protein could end up systemically distributed throughout the body, and which it could include the heart, right? So there's a mechanistic link. Now, having completely inert components of the vaccine distributed to a place like the heart, would not explain myocarditis, right? An inert protein is just that. When we say inert, it means it has no bioactivity. And if there's no bioactivity, there's no harm that can be done. And that is the optimal vaccine, we call vaccine antigen, right? When you're picking a target protein to put in a vaccine to target a pathogen, you ideally want that protein to be inert in the body if you're going to inject it into the body, right? But then I was also studying at that time the disease, and we were gaining a much better understanding of how the disease works. So in severe cases of COVID-19, this is how it worked, Leighton. People would get infected, be an upper respiratory tract infection. But in severe cases, so if people think about it, inherently, people may have had, especially if you're older, many of us will have had cases of bronchitis. And some of us will have also been diagnosed over a lifetime with cases of pneumonia. And we generally know bronchitis is not as dangerous as pneumonia. Bronchitis is when you have an infection of the upper lungs. The bronchi are those large airways in the upper part of the lungs.
Right.
But pneumonia is much more dangerous because that's when the pathogen gets into the lower part of the lungs, where the air spaces are. We call them the alveolar air sacs.
Right. Yes.
Yeah, exactly. The alveoli. So if a virus gets there, it can become very dangerous. Why? Because inflammation is the first step of an immune response. And it is remember I talked about the immune system generally being, working with great specificity. Well, the first step of inflammation is actually a relatively blunt tool.
Right.
And it can cause a lot of bystander damage. Yeah. Right. That's why if you're a tennis player and you get tennis elbow, you'll actually put an ice pack on it because you reduce the inflammation to reduce the off-target damage to the tissue from the severe inflammation.
Okay.
So it can cause a lot of damage. So inflammation in the lower lungs is dangerous because that's where air exchange occurs. And if you have that small airspace filled up with all kinds of inflammatory components, you can't get proper air exchange. Further, there's just the tiniest little cellular layer between those air spaces and the blood vessels to facilitate air exchange, right? We got to get carbon dioxide out of our bodies. That's what we exhale. And we have to get oxygen into our bodies so our cells can use that. That's what we inhale. So once a virus gets down there, it can cause a lot of trouble with breathing and gas exchange. And then there's the potential for that virus to cross that tiny little barrier and get into the blood. That causes a condition called viremia, where the virus starts getting pumped throughout the body, systemically throughout the body, through a process, this process of viremia. It's very dangerous, a very dangerous situation. And so the immune system, all the alarm bells go off, and the immune system responds. So what people tended to die from with severe COVID-19 was this severe, very severe systemic inflammation. So people wanted to study so that was causing a lot of harm to the body. So when people started studying, why does this virus cause so much harm to the body, including in people who would recover from severe infection, right, where they would not succumb to it, there were long-term consequences. And so we wanted to know, because again, if we can figure out what exactly from the virus is causing these problems, then maybe we can target those very specific components. And this is the thing. So to cut to the chase with this part, Leighton, here's the key. What was found out is the vast majority of damage being caused to the body acutely, that means in the short term with severe infection, and also longer term with people who had recovered from severe infection, was the spike protein. And at that time, that I raised my concern about the spike protein being a toxin, that meaning having bioactivities. So what a toxin is it means it's a protein that has bioactivities in the body that are harmful. That's literally what a toxin is. And so literally the spike protein was being defined as a protein that had multiple harmful bioactivities in the body. That's why I refer to it, and recognize I'm talking to a lay audience. That's why I refer to it as the lay audience would understand. This means it has toxic activity.
Right.
And there were multiple known. Now we're up to, Leighton, I don't even know the exact number, but we're at over 20 known potentially harmful bioactivities of the spike protein in the body. Now you can see where I was going. So honestly, Leighton, in that interview, I was very proud of myself afterwards because I thought it was cut off fairly short, but I was able to get into a very short period of time. As you can see, a very complete story. Yes, there might be a link between the shots and myocarditis.
Yeah.
And this is a potential mechanism. We know that at least in some people, that there's the potential for distribution of components or derivatives of the vaccine to the heart tissue as well as other tissues. But we were talking about myocarditis in that interview. And guess what? One of those things is the spike protein. And we know the spike protein has all kinds
Hmm.
of mechanisms of harm in the body. So now there's you see what I was trying to get out there was a potential mechanism to explain this potential
Yes.
link, a potential cause and effect relationship, right? The spike protein could potentially get to
Right.
the
Yeah.
heart, potentially cause myocarditis. And now all these years
Yeah.
later, I mean, the peer-reviewed scientific literature is very clear on this. People who have suffered post-vaccination myocarditis, when people have looked at their heart muscle, they're loaded with spike protein. Now, there's other, like I said, there's multiple mechanisms of harm, but one of the well-defined mechanisms of harm that can contribute to the myocarditis now, which is very clear, is spike protein getting to the heart muscle.
Hmm.
And it's so frustrating because so many people have suffered from that. So people have died from that, and people are suffering long-term disability from vaccine-induced myocarditis, right? And I highlighted that so long ago, and that's what I was trying to do. Was I was
Mm.
just trying to share as an academic, public servant. I was just trying to share the science with people so that they could
Hmm.
understand the full spectrum of the science and make
Hmm.
their own personal informed decisions,
Hmm.
right? And never did I foresee that the plans were in place to mandate these things. And so
Right.
you can see
And you
how,
oppose those mandates at the University of Guelph too. That was part of the reason why they attacked you, right?
oh, absolutely. In fact, they got very upset because that highlights another, but this is again another egregious rejection of science. So you might be interested. When my university implemented a vaccine mandate, one of the things that I did is I wrote an open letter to the president of my university, and I tried to explain to her the science. Clearly, some kind of politics overruled it because she never addressed even one of my scientific concerns. And this was the thing. I knew that many people around the world had naturally recovered from infections with SARS coronavirus 2. In fact, many of us never even got sick, right? That was one of the things that was not well understood. There's a difference between getting infected with SARS coronavirus 2 and having COVID 19. The D in COVID is disease. You have to be
Right.
sick to have a disease. You have to have
Right.
signs and or symptoms. And that has to be diagnosed by a professional diagnostician, like a physician, in order for you to have a disease. But many of us got infected and cleared it. And I was apparently one of those. I participated in a human clinical trial that was developing antibody tests, right? And a lot of people don't realize this, Leighton, at the beginning. I was in full support of this. There was actually a Canadian task force established with studying what we call seroconversion. It's looking for the emergence of antibodies in people's blood against SARS coronavirus 2. The reason why that's important
Mm.
is that if you have antibodies against the virus, there's only two ways that you could have those antibodies develop. One is through recovery from natural infection, and the other one is through vaccination, right? Where you simulate a natural infection, try to simulate a natural infection. Now, so of
Mhm.
course, early on, before the vaccines were rolled out, there wasn't the possibility of that being induced by the vaccine. So if anybody had antibodies, it was because they had responded to the SARS coronavirus 2. They, they have been naturally infected and recovered. That means, by definition, that would be evidence of naturally acquired immunity. Naturally acquired immunity, I can't emphasize this enough as a vaccinologist. Naturally acquired immunity is the gold standard to which we always try and attain when we're developing vaccines, new vaccines. We wish. We wish that when we develop a new vaccine and when we're testing them, it's like, please, please, please come somewhat close to recapitulating naturally acquired immunity. And if it does, we're probably going to have a good vaccine in our hands in terms of effectiveness.
Mhm.
Um, and so this is the thing, naturally acquired immunity. And I demonstrated proof of that. I actually showed my data. I'm not one who's into promoting public disclosure of private medical data, but this was one where I recognized science was not being recognized. I showed that I had responded. I had antibodies against multiple components of the virus. Very robust responses, evidence of robust responses. In other words, I had achieved the gold standard. I had naturally acquired immunity against SARS coronavirus 2. And I tried to explain to the president of my university that I had proof of immunity. She, on the other hand, had proof. She had certification of 2 needles having gone into her shoulder, with the hope being that they had led to the induction of an immune response against SARS coronavirus 2. Here's the thing: when you have an outbred population, Leighton, and you apply any medical intervention, including vaccines, you end up, the responses in that population end up taking the shape of a bell curve, classic bell
Okay.
shaped curve, right?
Okay.
Most people in the population will respond moderately well to the vaccine. There will be a tiny proportion of population that we call the high responders. They'll respond very rigorously to the vaccine. But you know what's at the other end? The other tail? Those are the low/non-responders, Leighton. So there will have been people who received those shots who didn't mount an immune response at all. Forget about a subpar response, which is the best that could be achieved with these shots. There were people who were complete non-responders. So I pointed out to the president of my university, for all we knew, she could be a non-responder. She had no evidence to prove that she was or was not. I had proof that I was immune. Remember, the whole purpose of a vaccine, the whole purpose of a vaccination program is to induce immunity in the population, as many people as possible. The goal is immunity.
Right.
So I had achieved the goal, and I had a proof of the goal. The president of my university had a certificate showing that she had taken a step towards that goal, right? She had got the shots, but she had no proof or evidence that she had actually mounted an immune response. And yet I was banned and told that I was unsafe to be around, right? And she and all the others on my university campus, most of the members of the university campus, right, took these shots. Many, many students and staff were coerced into taking them. So on the assumption, the hope that they had mounted immune responses against SARS coronavirus 2, they were allowed to engage in all the regular activities, and people like me were excluded. So that, again, I highlighted. And now this is the thing. And again, did I know what I was talking about as an immunologist? My goodness, like, it's crazy to even consider the fact. I have to look back and even consider that we had to try and defend this whole concept of naturally acquired immunity, that the immune system works without so-called hand of man or hand of person manipulation. And now we have, I can tell you, Leighton, I have now accumulated, I have read from start to finish over 130 peer-reviewed scientific studies now that all show, more than 130, that all show that naturally acquired immunity is superior in every way, shape, and form to the immune responses that can be induced by these shots. So not only is the goal to, and notice that I kept, when I was referring to these shots, I keep referring to we hope that they induced an immune response. I don't say immunity, because they couldn't come close to inducing immunity. Immunity means you are protected from the disease and you cannot transmit the causative agent of the disease. These things failed to be able to do that, which also means, remember, the whole purpose of these mandates was to try and encourage uptake of these vaccines to achieve herd immunity. And I can't emphasize this enough. It's actually really quite simple and straightforward, Leighton. You cannot achieve, it is 100% impossible to achieve herd immunity if you cannot achieve individual immunity. Right? It's just common sense.
That makes sense.
And I tried to promote these concepts and show how wrong this whole concept was, of trying to force people to take a vaccine that could not achieve the stated goal.
And you went further than that, actually. My understanding is that you wrote a book called COVID-19 Vaccines in Children, a Scientist's Guide for Parents, right? Is this what spurred you to write that book, or what was the impetus for writing the book?
Okay, that was because I received such brutal attacks from that interview that we just discussed. Okay. I was shocked. I actually went to bed that night feeling, you know what, I've done my job as a public servant. I've revealed some important scientific facts that are important for people to take into consideration when they think about whether or not they want to take these shots, right? Take it or leave it. That's always my attitude when it's a novel medical intervention. If you want to take it, awesome. If you don't want to take it, awesome. As long as either way, I just want to feel confident that you're making a fully informed decision. Either way, with whatever choice you make. It was unbelievable. There was a global, a very apparently well-funded, very well coordinated, professional, global defamation campaign had been launched against me, including things like there still to this day is a website that still exists in my name. Police have been investigating that. A criminal investigation
I
has
saw
actually
it.
been ongoing.
I saw it.
Yeah,
Yeah.
if they ever
Yeah. It's
identify
salacious.
who's responsible
Yeah.
for that, they will be charged with criminal impersonation. There's also an X
Wow.
account at the time, Twitter account, of course, that went up that has been used to impersonate me. Now they've changed it to try and get around this criminal impersonation aspect to labeling it as a parody account, but it still confuses people. Still uses my hashtag, um, and it's been used to defame me. And in the social media where I didn't have a presence, especially on X, all kinds of social media, the attacks were. Well, they have literally been relentless and incessant and chronic. Like they still
And
occur to this day.
you've responded
Still
with
occur
your
to
own
this day.
lawsuit, though, haven't you, Doctor? You filed the $3 million lawsuit
I
against them, right?
have, yeah. So there's a couple things. So it was in response to this unbelievable global defamation campaign that I wrote that book, because this is important. Not one of those people, not one of those 88 signatories on that letter that has been used to hurt me, Leighton.
Yeah.
Not one of those people, not one of the people who have attacked me in social media, not one person who has propagated the idea that I have spread misinformation of any kind. Not one has ever had the respect, or showing the professional respect to engage me in a conversation, to allow me a real-time conversation like you and I are having right now, to respond to criticisms.
That's appalling.
Instead, the trick that they play, and you're probably well aware of this, with all of your experiences over the past several years, you know how it is. They take something that we say. They could take something that we say in our conversation right now, right? They could take something out of context. One thing that we say, go search on the internet, find something, anything that seems to contradict it, and then advertise that we're spreading misinformation. Or most of the time, they don't even provide any evidence. They just say we're providing misinformation. Now, if they said that something that you
That's
said
the game.
during
That's
this
the
interview
game.
is misinformation, yeah, but it's a real-time conversation. You can immediately respond, right? And then people who are watching that are going to be able to see that you know what you're talking about. You know how to respond to all these criticisms, and you can defend yourself. But instead, they try and make us defend ourselves against comments being made by thousands of people around the world, right? And they try and spread out our time and energy, and we can't do it all. So not one person was willing. And in fact, what happened is I had colleagues at my institution accused me of harassing them because I kept trying to engage them in conversations about the science. And it literally got to be ridiculous. I tried to engage them by email, and then they said, we find this harassing. We don't want you to engage us by email. And they got the university administration to issue, a communication to me saying you're not to engage these people in email anymore, right? If I tried to engage them in person, I was told I can't engage them in person anymore. Got to the point where in the interview with the heart issues and my concern about children in particular, which was the extreme end of the risk benefit analysis, when multiple articles in the UK came out expressing their concerns about these shots for children, in large part related to the myocarditis issue, I slid those under their office doors because I wasn't allowed to communicate with them in any other way. They accused me of harassing them because I put these articles,
harassing them with truth,
under this, and always recognizing it's not like I'm just doing this after the fact with them not doing anything. The whole time they are actively attacking me. They're actively degrading my character. They're defaming me the whole time. And so people have to understand, well, why did you keep trying to engage with them? I kept trying to engage with them because they kept harming me. They kept publicly harming me. And they kept accusing me publicly.
Right. And you wanted to get the truth out. You want to get the truth out.
Exactly. Yeah. So not one person would engage. And so, you know what I did? That's why I wrote that book. Is I quickly worked on that. And I said, before anybody accuses me, here's a book. Here's all kinds of the science. Look at it. Read it. Look at the publications. Look at the reasoning behind that. Because remember also, in that 9-minute interview, it was off the cuff, just like right now, and to a lay audience, just like right now. And yet every word I was saying was being evaluated as though I had claimed to have written the gospel truth, right? As though I had claimed to have just presented, to have been publishing, a
like a
peer-reviewed paper.
PhD thesis or something. Yeah.
Exactly. So I wrote that. Now, this is what's particularly egregious, Leighton. I wrote that, and then following the release of that book, that is when this letter with 88 signatories
Yeah.
from my university accused me of spreading misinformation. Again, my ability to communicate with those people was incredibly limited. But what I want you to know, I was able to engage very briefly in conversations with 4 of those signatories. So not all 88, but 4 of them. Of those 4, I said to them that I was very disappointed with them having written this letter without asking, what the reasoning was for my concerns, allowing me to share with them. But I said, you won't engage me in any kind of discussions, any form of communication. But I said, please assure me that you read that book before you signed that letter. That's all I want to know. Because because at least if they read that and had considered all the science and they still disagreed with me and signed the letter, at least they had considered what I had said. You know what? All 4 of those 4 people that engaged told me, Leighton, they hadn't even bothered to read it, and they signed that letter.
Wow.
And this is this is continued to this
yeah.
day. But people have to recognize this is how bad it is.
Yeah.
Science, and these are people who I was friends with. We did social things together. We got along great. We would walk into one another's offices on a daily basis and ask one another questions about science, the collaborations we were doing, the committees we were serving on, the teaching we were doing, all the time. And then all of a sudden, just like a switch, right? That I did that interview and nobody would engage me. It was that's actually what I found to be the most frightening part of all of this, is literally the basic foundations for the practice of science have disappeared, including open discussions of contentious scientific topics. So there was this idea then that was propagated that, look at my public messaging. Apparently, was so far off from, and you've heard this term before, many of your listeners well, right? The global scientific consensus, which of course we now know it appears like there's a consensus when you silence those who have differing opinions, that I must represent, I must have lost my mind, right? And represent a threat to those on campus. And so on the basis of these feelings, that I could potentially represent a threat because look at my, my messaging and how out of sync it was with the so-called global consensus. To this day, I'm not allowed back on campus. And so I'm fighting that. So yes, so this is the thing. With respect to, this went on for so long, and I tried all kinds of methods to get access to my laboratory and my office. So what's interesting with this, Leighton? First, it started off with no justification given. I was banned from my entire campus. And then, with no explanation given, I was suddenly allowed to access my entire campus except the building that houses my lab or my office. So I could go to the cafeteria and get lunch if I wanted. That doesn't do me much good. I couldn't do my job because I couldn't access my lab or my office. So all of a sudden, this concern of me being on campus, first of all, it was interesting because it was limited to the boundaries of the campus. Nobody had any issues or perceived me as a threat outside of the campus boundaries. And then all of a sudden, without any explanation given, the concern about me being a potential threat on campus was then dramatically reduced from the campus boundaries to the boundaries of my building. And the crazy thing is, of my colleagues who were attacking me the most, only half of them were in that building. So you know what I mean? So it was just crazy from a legal perspective. Like there seemed to be no rationale for these rules that they were making up. But I tried all kinds of things. I went so then when I had exhausted all possibilities, yes, I had no choice but to try and rescue my career. I launched a civil lawsuit. Now, what should have happened is my university's faculty association, which is the union that's supposed to represent faculty, like all unions, right, should have represented their workforce. They refused to defend anybody who had been discriminated against based on these policies that were put in place at our university. So they should have been the ones who launched a workplace grievance, right? It should have been a workplace issue. but they were unwilling to, so I had to go through a civil lawsuit route. Now, this is the thing. Since then, they've now explained to me, they've told me, everybody was scared, nobody knew what was going on at the time, to which I've corrected everybody, saying, no, there's many of us who did know what was going on at the time, and you know that I'm one of them, and that's why I spoke up at the time. But nevertheless, they now, a long time later, but thankfully have finally, launched a grievance, right?
Oh, good, good. The
Against
power of
Yeah,
litigation, power of
yeah.
truth. Well, Dr. Bridle, your book is now on our reading list, and I'm going to urge our readers and listeners to read it. I'm also going to refer them to something called the COVID Chronicles, and this is on your Substack page, which has now over 24,000 subscribers. And the description says science-backed information to dispel the rampant disinformation being propagated about SARS-CoV-2, COVID-19, early treatments, and the current inoculations. And you've heard, folks, that this eminent expert has read more than 130 peer-reviewed articles on this topic. He's an expert in immunology. He's written a book about it for scientists so that they can understand it. And so if you want to learn more about the topics that we've been covering today with Dr. Bridle, that's where you go. Check out his Substack, subscribe to it, and you'll learn a great deal more. I am a subscriber now, and I look forward to learning more about this topic. And Dr. Bridle, we want to thank you so much for taking this time with us. I consider you to be one of the heroes in science. I put you in the pantheon with Dr. Jay Bhattacharya and Dr. McCullough and others for being someone who has told the truth to us about what's really going on, and without really any regard for your own reputation and your own safety. What you've done is truly courageous, and I think in the fullness of time, you will be properly regarded as one of the top scientists in Canada and indeed the world, and one of the people who should be regarded as a hero rather than a villain to the University of Guelph. But we want to thank you so much for being our special guest today on Grey Matter.
Yeah, I appreciate that. Thank you so much for having me, Leighton. And just one quick thing to point out: those 130 papers, over 130 that I read, was specifically only to do with naturally acquired immunity. I've actually read more than 1,000 peer-reviewed scientific articles now on the broader area of COVID-19 science. I understand it.
There it is, folks, and that treasure trove is on the Substack, so check it out. Thank you, Dr. Bridle.
Thank you. Take care.